Hi, we're just going to go over real quick practice solving equations. So if you've gotten this far, hopefully you already know what a variable is, but a variable is an unknown number that we're looking to try to find. For example, if I said, oh, that's a big red line there, 9 plus, I'm going to use the variable x equals 11. You don't have to do anything fancy. You could just think of this, what plus 9 equals 11? Well, you would probably think right away 2, because 9 plus 2 equals 11. But we can actually solve this using algebra, a property called the additive inverse. And we also have the multiplicative inverse that we're going to use as well. So for this one, we want to get x by itself. We want to know what does x equal. So we can use the additive inverse to get rid of that 9. So I can subtract 9 from the left side of my equation. But in order to keep my equation balanced, I have to do the same thing to the right side of the equals. So I'm going to draw a dotted line here so you can see what I'm talking about. That side of the equation there. So once we do that, 9 minus 9 is 0. So we are left with x equals 11 minus 9, which is 2. And that's exactly what we said earlier. We know that 9 plus 2 equals 11. We can check that by substituting our variable in to our equation. So we would say 9 plus 2 equals 11. 9 plus 2 is 11. We simplify that. 11 equals 11. This is true, of course. So we have done it. So not only do we have the additive inverse, but we also have the multiplicative inverse. So let's take a look at what that looks like. We could have something, for instance, like this. 6x equals 18. So this reads as 6 times a number equals 18. Well, of course, if you think about that for a second, we know that 6 times 3 equals 18. But how can we solve this algebraically? Once again, this time instead of subtracting or adding the opposite, we can multiply by the opposite. So what we're really doing here is, instead of subtracting 6, because we want, if this is 6 times x, we're going to do the opposite. It's easier just think of that as we're dividing by 6 on this side and dividing by 6 on this side. And while we do that is, just a sidebar here, 6 divided by 6 equals 1, right? So now we have 1 times x, which is just x, because 1 times the number is itself. So that's why we're able to divide by 6, to sort of clear that left side of our equation and get x by itself. So we are left with x equals 3 right there. We can check that by plugging in our numbers. 6 times x, we're saying is 3, equals 18. 6 times 3 we know is 18. That does equal 18. This is true. Put a nice big check. We are done here. No problemo. So let's look at something a little more difficult. What if we had something like this? 9 plus 6x equals 8x plus 5. Alright, so there's a bit more going on here. But remember, what we want to do is we want to get our variable by itself. So we want to make sure that all our x's are on one side of the equation, and we just have at the end x equals a number. So looking at this one right here, we can do two things here to get x alone. We can subtract a negative 6x from both sides to move our 6 over to the right, or we could subtract 8x, so move our x's to the left. I'm going to move our 6x over, because then our x will still be positive, so it just sort of saves a step. It actually doesn't matter either way, but I'm going to do it that way. So I'm going to take 6x from the left, and I'm going to basically move it over to the right. So what that gets us then is 9 plus 0, so I'll just write 9 equals 8x minus 6x. So now I'm left with 2x, and then that plus 5 is down there as well. The next thing I want to do to get x by itself is, of course, I want to get rid of that plus 5, because it's cramping my x's style. So we know we can do the additive inverse and subtract 5 to remove that 5, but I have to do the same to the other side. So I'll take away 5. So I'm left with 9 minus 5, which is 4, equals 2x plus 0. I don't need to write that because it's nothing. Now 2 times a number, x, equals 4. I think you can solve this using mental math, but let's say you couldn't. To get the opposite of multiplication here is division, so we can divide both sides by 2. 2 divided by 2 is 1, so we have 1x, which is exactly what we wanted. 4 divided by 2 is 2. So our answer is x equals 2. X is on the right side, but that doesn't matter. Let's give it a quick check. We'll substitute our x in there. 9 plus 6 times 2 equals 8 times 2 plus 5. Running out a little space there, but that's okay. 9 plus 12, right? 6 times 2 equals 8 times 2 is 16 plus 5. Hopefully this works out. 9 plus 12 is 21, and 16 plus 5 is 21. This is true, so this is a solution. Alright, let's look at another one. This one we're going to examine the distributive property, which I hope you know, but you'll see what it is in a second. So on the left side we have 2 parentheses 7 plus 5w. So this is where we're going to distribute, and that equals 6 times 2w minus 1 in parentheses. Double distributive property. Wow. So let's see how that works. Before we even go messing around with our equation here, I'm going to simplify it by using the distributive property. So if you're not aware of what that is, we can distribute this 2 to each of the numbers inside of our parentheses. So it's the same as 2 times 7 plus 2 times 5w. So if we write that out, our new left side would look something like this. 2 times 7 is 14. 2 times 5w is 10w. So now we've removed that 2 and the parentheses. We've distributed it to the inside of the parentheses. We can do the same with the other side. 6 times 2w minus, be careful, minus 6 times 1. So let's write that out. 6 times 2w is 12w. 6 times 1 is 6, and don't forget that's that minus, so it's a minus 6. Right, we've cleared our distributions out there, and now this looks pretty familiar to our last problem. Once again, actually just to shake it up, we're going to get rid of the bigger, the 12w, and we're going to move that to the left, so I'll see what happens with that negative number here. So let's get those w's together. I'll remove that 12w from the right side over to the left by subtracting 12w from both sides. That's going to leave us with 14 minus 2w equals 0 minus 6. Don't need to write the 0, so I'll just keep it negative 6. Alright, the next thing you'd want to do is we want to get w by itself. We've got it all on the left side. Awesome. Let's clear away that constant. So 14, to get rid of that, we use the additive inverse. We can do minus 14. Have to do the same to the other side, of course. And we are left with 0. Don't have to write it. Minus 2w equals, and this is negative 6 minus 14, so that's going to be negative 20. Now we are left with negative 2 times w equals negative 20. Once again, I think you can work that out in your head what the answer should be, but let's use the multiplicative inverse here. So we can divide both sides by, be careful now, negative 2. It looks a bit silly there. So we are left with w equals negative 20 divided by 2 is 10. That is our solution. Shall we check it? Alright. Let's give it a check. Hopefully I'll have to write a little smaller. Okay. I'm just, you know what? We'll do it this way. 2 times 7 plus 5 times 10. Nice. Got it in there. Equals 6 times 2 times 10 minus 1. Okay. So that's the original problem, undistributive. Let's work that out. Ooh, I'm missing a parenthesis there. Alright, 5 times 10 is 50. 50 plus 7 is 57. I'm going to skip a couple of steps there just to save some space. Equals 6. Let's do a parentheses. 20. 2 times 10 is 20 minus 1 is 19. Alright, we're looking at some big numbers here. That's okay. 57 times 2 is 114. And 6 times 19 is also 114. So this checks out. Our solution of w equals 10 works. Fantastic. All right, just for fun, if you want to hang with me, we're going to do one more. In this one, our last one, we're going to combine like terms. So let's take a look. So I have a nice big long equation here, so I'm going to leave tons of room. We're going to use the variable r here just to change it up instead of x, because a variable could be any number or any letter, or both actually. Alright, so this big long equation might look intimidating, but it's actually quite simple. So it's 10r plus 4 plus 9r equals 6 plus 4 plus 4 plus 9r. So before we jump in there, let's take a look. What are our like terms? Because I want to get those together and rearrange our equation here so it's a bit simpler for us to read. So I'm going to underline all the r's here. We have 10r and we've got 9r on this side. On the right side we've got 4r and we've got 9r. So those are our sort of our variables there. And if we look at our constants as well, on the left side we have a positive 4. Oh, that's it. And on the right side we have a positive 6 and another positive 4. So let's kind of rearrange our problem here. We can do that mathematically, it's no bother. So I'm going to write 10r plus 9r. Those are my r's on the left. We then have our one constant plus 4. So I've just rewritten that there so that those like terms are together, because I'm going to be able to add those or do whatever I need to do to simplify them. On the right side we have 4r plus 9r, and we have two constants, plus 6 plus 4. Okay, that's not too bad now. Let's stick with my little color coding here. Let's simplify. 10r plus 9r on the left there is 19r, and we still have that plus 4. On the right side we have 4r plus 9r, that is 13r, and we have 6 plus 4, which is nice, is a positive 10. Alright, now we can go about solving this equation as we have done before, now that all of our constants are together. So let's go ahead. Let's get all the r's on one side. I'm going to move the 13r on the right over to the left. I can do that by subtracting 13r from both sides. So 19r minus 13r, we now are left with 6r. I'm going to write back all in red, plus 4 equals 0. Don't need to write that. And 10 plus 10, so positive 10 there. 6r plus 4 equals 10. Let's get those r's by themselves. So I can subtract 4 from both sides to get rid of that positive 4. So then I am left with 6r plus 0. Don't need to write the 0 because it does not there. 10 minus 4 is 6. We are left with 6 times a number r equals 6. So once again, mental math, you've got this. You could figure this out, but let's use our properties to determine it is. We can divide both sides by 6. Use that multiplicative identity property. 1 times the number is itself. We are left with 1r, or in this case just r, equals, ooh, look at that, 1. That is it. Let's just give it a check real quick to confirm. I'll do my check in purple. So I'm going to substitute r in all of our r's there. So 10 times 1 plus 4 plus 9 times 1 equals 6 plus 4 times 1 plus 4 plus 9 times 1. Okay, now these ones are going to make it pretty easy for us, so I'm going to multiply those all out. So 10 times 1, of course, is 10, plus 4, plus 9 times 1, which is 9. We got that. On the other side, 6 plus 4 times 1 is 4, plus 4, plus 9 times 1 is 9. Alright, let's add these bad boys up. 10 plus 4 plus 9. I'm going to do it all in one step. 10 plus 4 is 14, plus 9 is 23. On the other side, 6 plus 4 is 10. plus 4 is 14, plus 9 is 23. 23 does equal 23. This checks out. R equals 1 is a solution to this equation. Let's just examine if this is not the case, just for fun. Let's say I said R equals 2. I did something wrong. I said R equals 2. I said I'm done. You know what? I'll check it just to make sure. So let's try that out real quick. What would happen? 10 times 2 plus 4 plus 9 times 2 equals 6, plus 4 times 2 plus 4 plus 9 times 2. Alright, let's do this math real quick. 10 times 2 is 20, plus 4 plus 9 times 2 is 18. 6 plus 4 times 2 is 8, plus 4 plus 9 times 2 is 18. Getting there. 20 plus 4 is 24, plus 18 equals 6 plus 8 is 14, plus 4 plus 18, I'm going to add those two, plus 22. 24 plus 18 equals 42. 14 plus 22 is 36. Take a look. Does 42 equal 36? Not in this world. So R equals 2 is not correct, and we can tell that when we check it. So it's always good to give it a check, just to make sure that you did indeed find a solution. If you did find something wrong, it didn't work out at the end, more than likely there's an error along the way, but at least you know that you've made a mistake, and you can go back and see if you can figure out what went wrong. Alright, good luck solving those equations, and see you next time.